teacher have these. Some kind of knows.
I don't know.
Kind of weird.
Yeah.
94? Jeez. You're so young.
Featuring Vice President Al Gore, maybe. He could have just meant like.
Al Gore is also a big environmentalist,
Yeah.
so that's probably partially why it is. All right, what do I do with my clicker? That's a great question.
Somebody just stole.
No,
I
I probably no. I'm misplaced it. All right, so 7.1, energy in living systems. So the section questions that we would be able to answer by the end of this are: what is the importance of electrons for the transfer of energy in living systems? And how is ATP used by the cell as an energy source? All right, so what is cellular respiration? Anybody know? Go ahead.
ATP.
It makes ATP, right? It makes ATP. It's a set of metabolic reactions and processes that take place within cells of organisms to convert energy from glucose, usually going to be glucose, to ATP, adenosine triphosphate, and then release waste products. You know what waste products are? No, carbon dioxide and water. Those are waste products of cellular respiration.
Is that a pizza with no cheese?
I saw this picture on Google. It's a shroom.
Really?
That's a
Oh.
shroom.
That's a weird looking shroom. The red thing?
All right, the formula for cellular respiration is C6H12O6 plus 6O2 yields yields 6 CO2 plus 6 H2O and chemical energy in the form of ATP.
How do you do the
You should, it's either control comma or control period.
Yeah, it's control
Okay.
on.
Are we to the point where we're going to need to know this?
Yes, you need to know this. You need to have this memorized.
Then how do you get out of it?
Do it again.
And just take a picture of them.
No.
Well, I can take notes.
Wait, what do you mean you can't take notes? You get
Yeah,
paper
it's
and
back up.
pencils? Is it back up?
Yeah. It let
Hey,
you
there you
let
go.
it.
Look at that. Yeah, like find a way, ladies and gentlemen.
Still.
So if you look at this picture, there's actually 3 different stages in cellular respiration. We're going to go over all of them. There's glycolysis, there's the citric acid cycle, this is also called the Krebs cycle, and then there's the electron transport chain. Again, this is important because it's a cycle between photosynthesis and cellular respiration. If you look at this equation and put it backwards, that is photosynthesis.
How do you do the arrow?
Insert special characters. Or you can do a dash and a caret thing. Alright, so cells extract energy from food to make ATP in a process called glucose catabolism or cellular respiration. Remember, catabolism or a catabolic reaction, what does it do? It
Breaks things down.
breaks things down and will release
Energy.
gives off energy, okay? So as we work in the metabolic pathways involved, notice a close link between the transfer of energy and the movement of electrons. Electrons are usually going to be the energy carrier in these processes. They have high energy levels. This transfer of electrons allows cells to transfer food energy into small packages that can be captured in the phosphate bonds of ATP.
I think I memorized something.
Good.
That's right.
You should know it backwards and forwards, literally.
Hold on.
Yes.
Oh, I'm still connected to the phone.
C6H12O6 plus 6O2 yields 6 CO2 plus 6 H2O plus energy.
And what is that?
That's the formula for cellular respiration.
Yes.
No, C6H12O6.
C6H12.
You can just Google the formula for cellular respiration.
That's what I did in copy paste.
Yeah. All right, so the stages of.
You said the internet.
No,
Cellular
I'm
respiration.
just on his phone.
Are you still hooked to my phone?
Uh-huh.
Stage 1 is glycolysis. Stage 2 is the Krebs cycle. Stage 3 is the electron transport chain. So this is actually the picture from your CK12 book. Glycolysis takes place where?
Cytoplasm.
The cytoplasm. Where does the Krebs cycle take place?
Mitochondria.
Specifically in the matrix of
In the
mitochondria.
matrix.
Electron transport, where does that take place?
In the
Mitochondrial
layer.
membrane.
In the inner membrane of the mitochondria. Alright, redox reactions. You haven't had chemistry, so this is going to be interesting. Okay. Say what?
Interestingly painful.
We'll see. These are reactions where electrons are transferred from one molecule to another. The reason this is important as we start getting into the nitty-gritty and the molecular stuff of cellular respiration and photosynthesis, a lot of it's about moving electrons around. Basically, in some way, shape, or form, we have high-energy electrons. Those high-energy electrons either become highly energized from getting hit by the sun, in the case of photosynthesis, or by breaking down glucose in the case of cellular respiration. And then these electrons just move around. And as they move around, they lose energy, and that energy they lose is used to push something across a cell membrane. Okay, does that make sense? Molecules that can donate electrons in a redox reaction are called reducing agents. Those that can accept electrons are called oxidizing agents. So if it can donate, it reduces. If it accepts, it's an oxidizing agent. There's a phrase in chemistry called oil rig or Leo says grr.
So what now?
Yeah. So what gets kind of difficult is reducing agents are oxidized, but oxidizing agents are reduced. And so it gets really confusing. There's a phrase that's called Leo says grr, LEO, losing electrons is oxidation,
Oh.
GER, GER, gaining electrons is reduction.
Okay.
Or the other one is oil rig. Oxidation is loss of electrons, OIL. Oxidation is loss. Reduction is gaining electrons.
Okay.
RIG. Molecules that gain electrons after reaction are reduced. Those that lose electrons are oxidized. So Leo says GER, losing electrons is oxidation. Gaining electrons is reduction. Or oil rig. Oxidation is loss of electrons. Reduction is gaining electrons. This is kind of an example of a rough thing. We've got a reducing agent, oxidizing agent. The oxidizing agent will gain electrons. Electrons have what charge? Negative. So we go from a positive to neutral. The reducing agent loses electrons. We go from a neutral to a positive. Right? So that's what the electrons are kind of going. That makes sense a little bit. Do you know what chemical bonds are?
Yeah.
What?
Bonds between chemicals.
Yeah. What are they made of?
No.
Y'all answer that one real quick. What are they made of? What are chemical bonds made of? Specifically covalent bonds.
Isn't it like shared electrons?
Yeah, shared electrons. In the case of ionic bonds, it's transfer electrons.
We did some like
Yeah, we did a little bit of that.
adding and stuff, chemical equations or balancing chemical
Balancing
equations in
chemical
like 8th grade.
Yeah, we
Wait,
did.
Good.
I was goaded at those.
I was so bad at that.
Those were so those were my favorite.
Molecules like nicotine, amide, adenine, dinucleotide, NAD can occur in an oxidized state, be positive, and a reduced state, which is neutral. Okay? These two forms of this are important in cellular respiration because these are electron carriers. That's what we'll refer to them as. This is without electrons. This is with extra electrons. Okay? These help move electrons from one part of the cellular respiration system to another, specifically usually from the Krebs cycle or the citric acid cycle to the electron transport chain. NADH carries 2 electrons and 1 hydrogen ion more than the NAD. NAD is called an electron carrier because that's what it does. It carries electrons from redox reactions, and then NADH will be the donator. So it carries it. Y'all kind of follow that. NAD plus accepts electrons, and then this one will donate them. These are important molecules in cellular respiration and photosynthesis. When we get to photosynthesis, we've got an NADPH, which is the photosynthesis electron carrier. In cellular respiration, it's going to be NADH and then FADH2. Those are the two. They basically move electrons around to electron transport chains where ATP is made. So if we look, so the goal is, what's the goal of cellular respiration?
To create ATP.
To create ATP from glucose, right? We've got 3 stages in cellular respiration. Glycolysis makes 4, but you have to input 2, so we have an NM2. Krebs cycle makes 2 ATP, and then we've got the electron transport chain, which is 32, 34.
What?
So most of your ATP in here is made in your electron transport
We
chain.
should get close to that age specifically 34.
So
Yeah.
I need to go back and find out why they say 32 and 34. It's some reason about some ATP getting recycled somewhere back up there. Or
So
something
just
like
takes
that.
the ATP that's already made.
Yeah, essentially. That's my guess, right? But that's where most of your ATP is made. Oh, no, too far, huh?
Nah.
Electron carriers are very important. Yeah. They shuttle electrons. Other electrons are FADH2, FAD+, NADP+, and NADPH. This one's going to be in photosynthesis. This is another one that will be in cellular respiration. Vision is going to look like this.
Nice.
This is where your 2 electrons are hanging out. That extra hydrogen bond. Because how many electrons are in one covalent bond?
2.
If it's a double bond, it's 4. Triple bond, it's 6.
Just triple one?
Yes.
I remember.
ATP, again, this is the energy currency of the cell. The hydrolysis of ATP to ADP and an inorganic phosphate is exergonic. That means it does what?
It
Releases energy.
Oh yeah.
Okay.
Exerts energy.
It can provide energy for coupled inorganic reactions. The loss of the phosphate group, specifically this gamma phosphate group, is called dephosphorylation. It's a long word, huh?
No, photosynthesis is longer. I had to spell that once for a teacher. I don't know why.
Is he in trouble? Not my hand.
No, I think she didn't believe I had to spell it. So.
I got a question for you, Preston. What were your first thoughts of me when I showed up?
I didn't like you.
And that's
Oh,
okay.
like
Yeah.
when you first got here and started teaching?
Yeah.
Oh yeah, I hated it.
Like,
Yeah.
it breaks in a little bit.
Yeah.
Yeah. And
I was a
hey,
freshman this year liking you.
not too bad. I think it helped that my reputation was kind of ahead of myself.
Louis
Well,
still doesn't like you.
Say what?
Louis still does not like you.
That's okay.
He complains about you every morning on the bus. Like, I have so much work to do for this I'm like, yeah.
Yeah, here's the thing. If he did it every day, it wouldn't be as much. Because he actually finished like 9 weeks of material in 1 night. So,
Yeah.
like, yeah, why don't you do that every day? It doesn't take you 6 hours.
Do we need to know that big word?
Which one? Dephosphorylation?
Yeah.
I'm not going to make you know it, but you should be able to read it and know what it means.
Okay.
So D means without. Kind of like, what's a good thing? I don't know. Yeah, dephosphorylation means you get rid of a phosphorylation.
Like decompose.
Yes, like you break it down.
When do you think they'll put in like those checkers? Like
Probably this Sunday.
Oh boy.
no.
There goes my grade.
Alright, phosphorylation is the process of adding a phosphate group. So you get rid of it, it's called dephosphorylation. If you add it, it's called phosphorylation. Phosphorylated molecules tend to be less stable and more likely to react. So example here, this ATP loses a phosphorus, or loses that inorganic phosphate. That is called what?
ADP.
Dephosphorylation. But this protein that it's doing, this is now
Phosphorylated.
phosphorylated, okay? And usually, the thing that's going to get phosphorylated is usually going to be a protein. That's actually how they work, specifically active transport. The protein becomes phosphorylated and then changes shape. ATP is generated by an inorganic reaction where ADP undergoes phosphorylation. ADP plus inorganic phosphate yields ATP. The energy from this reaction either comes from a coupled exergonic reaction or a process called chemiosmosis, which requires the enzyme ATP synthase. Most of the time, most of your ATP is made this way in chemiosmosis. That's actually what the electron transport chain preps for. Coupled exergonic reaction at substrate level, that is where the ATP is produced from glycolysis and the Krebs cycle. But most of it comes from this chemiosmosis, which is just the osmosis of chemicals, specifically hydrogen ions. Three hydrogen ions. And then, yes, in the mitochondria. 90% of the ATP is produced by chemiosmosis. This occurs in the mitochondria, also in chloroplasts, and in the plasma membrane of aerobic prokaryotes. Alright, there you go. We'll finish these tomorrow and try to get through most of glycolysis as well. I will try to post this on YouTube today.
Alright.
What's up?
Am I allowed to build a guard like